Hi guys, let's talk about the binomial probability distribution. So when we talk about the binomial distribution, there are four things that have to happen before we know it's binomial. One, there has to be a fixed number of trials. Two, the trials have to be independent. Three, each trial has to have one of two outcomes, and we call those outcomes either a success or a failure, which is why they are mutually exclusive outcomes. And then four, the probability of success has to be the same in every trial. So it's just the notation that we're going to use. N is going to be the independent trials, how many we have. P is going to be the probability of success. So the probability of a failure is going to be 1 minus P. And then X is going to denote the number of successes we have. We can also talk about the mean and the standard deviation of a binomial random variable. Remember, when we talk about mean, we're talking about using this Greek letter mu. And when we talk about the standard deviation, we're talking about the Greek letter sigma. So the mean is just n times p. N is the number of trials, p is the probability of success. Sigma is the square root of n times p times 1 minus p, which is the square root of the number of trials times the probability of a success times the probability of a failure. And we're going to use StatCrunch to help us compute our binomial probabilities. Let's look at a few examples. So let's look at number 1. N is 10, so we have 10 trials. The probability of a success is 0.4, and X is, we're looking for 3 successes in this case. That's what X equals 3 means. So we're going to open up StatCrunch. We're going to go Stat, Calculators, and Binomial. And let's type in the information we have. We know N is 10. We know the probability of success is 0.4. And we're looking for X to be equal to 3. So I'm going to click here. There's a drop-down menu. And my equals to ends up being the last one. Let me move the calculator. I'm going to round this to 4 decimal places. So we're going to get 0.2150. 0.2150 for that. And notation we're going to use, we're going to say P of X is equal to 3. So that means we want exactly 3 successes, whatever a success is defined to be here. Let's look at number 2. So N is 50. Our number of trials has changed. The probability of success is higher. And we're looking for exactly 38 successes in this case. So we're looking for P, X is equal to 38. Going to StatCrunch. N is 50. Our probability of success is 0.99. And we want exactly 38. And I want you to notice the scientific notation here. We've got 8.28 E negative 14. That means we want to move that decimal 14 places to the left. And then we're going to put zeros in front of that. So we would have 0.000, 13 zeros there, and then the 8. So that's going to be a super small number. So we're going to say that's approximately equal to 0. Number 3, notice our X has changed. We want the probability that X is less than 5. So if we go to StatCrunch, N is 10. The probability of success is 0.65. And we're looking at strictly less than 5. So I'm going to click this equals. And we want this one. So we've got about 0.0949 there. 0.0949. So a little less than 10%. And then a number 4. We are looking for X is greater than or equal to 12. So that means the probability of 12 plus 13 plus 14 plus 15 all the way up to 20. Stat crunch. N is 20. The probability of success is 0.7. And we want greater than or equal to 12. Compute. And 0.8867 will be our probability. 0.8867. Let's look at the mean and the standard deviation. For number 1, we want to find the mean. The mean is n times p, which in this case would be 10 times 0.4. We're going to get 4. Standard deviation, remember, is the square root of n times p times 1 minus p. So in this case, it's going to be the square root of 10 times 0.4, and 1 minus p would be 0.6 in this case. And if we plug that in our calculator, we'll get about 1.55. If you want to pause the video and try that, you can do that. Let's look at number 2. The mean is n times p. Our n is 20. Our p is 0.7. And if we plug that in the calculator, we will get 14. To find the standard deviation, it's going to be the square root of n times p times 1 minus p. So it's going to be 20 times p, which is 0.7, times 1 minus p, which would be 0.3. And if we substitute that in the calculator, we'll get about 2.05. Now let's look at a word problem. Let's pull some information out here. It says, suppose 15 flights are randomly selected. So we know n is going to be equal to 15. And we know that they are on time 80% of the time. So the probability of a success here is 0.80. A is asking us to explain why this is binomial. To be binomial, 4 criteria have to be met. The probability of success has to be the same in every trial, and in this case it's going to be 80%. There has to be a fixed number of trials. In this case we have a total of 15 trials. Outcomes have to be classified as either successes or failures. In this case, a success would be a flight's on time, so the failure would be the flight's not on time. And then every trial has to be independent. And in this case, one flight time is not going to affect another flight time, so they are independent. B is asking us to find and interpret the probability that exactly 10 flights are on time. So we're looking for P of x is equal to 10. Go to StatCrunch. Our n is 15. Our probability of a success is 0.8. And we're looking for exactly 10. Compute. So 0.1032. So what that means is about 10% of the time we would expect 10 flights, exactly 10 flights, to be on time. C is asking us the probability that fewer than 10. So that inequality is going to be important here. We want strictly less than 10. Our n and p are going to stay the same. What changes is this inequality. And notice when I change that inequality, this changed. So our probability is 0.0611. 0.0611. So that means about 6% of the time we would expect less than 10 flights to be on time. D is asking us the probability that at least 10 flights. So now the inequality we're using is greater than or equal to at least 10. We're going to change our inequality to greater than or equal to, and our probability changed to 0.9389. 0.9389. So almost 94% of the time, we would expect 10 or more flights to be on time. And then E is asking us the probability that between 8 and 10 inclusive. Inclusive means we're going to include those endpoints. So our inequality will look like this. And then to use StatCrunch, we're going to choose the between in the binomial calculator. Our N and our P stays the same. We want to be between 8 and 10. So this will compute the probability of 8 plus the probability of 9 plus the probability of 10. And we're going to get about 16%. Let's look at one more example with a mean and a standard deviation. So if we read through this, the probability of a success is still the same as the last problem, still 80%, but our N has changed. Now we're looking at 100 flights. A is asking you to compute the mean and the standard deviation for this. So if we want to find the mean is going to be N times P. So in this case, it's 100 times 0.8, which is going to be 80. So the interpretation of the mean, that's part B. This means that if we were to have 100 flights that are randomly selected, then we would expect 80 of those flights, or 80% of those flights. We would expect 80 of those flights, which is 80% of 100, to be on time. We randomly select 100 flights. We would expect 80 of those to be on time. Standard deviation, it's the square root of N times P times 1 minus P. So it's the square root of N times P, which is 0.8, times 1 minus P. Let me erase this. So 1 minus 0.8 is 0.2. Make that decimal a little bigger. So if we calculate that, I'm going to bring the calculator up. It's 100 times 0.8 times 0.2. Then we're going to take the square root, and we're going to get the nice number 4. C is asking us, would it be unusual to observe 75 flights on time for this? So we need to find the probability that X is going to be equal to 75. We're going to go back to the standard calculator. In this case, our N is 100. Our P is 0.8, and we want exactly 75. Now I want you to notice this. Look at that E negative 51. That means we need to move that decimal 51 times to the left, okay? Which means we are going to have 50 zeros in front of that too. So this number is approximately equal to 0. It's super small. Since it's less than 5%, 5% is the cutoff for normal. Anything above 5% would not be unusual. It would be considered normal or usual. Anything less than 5% would be considered unusual. So we would say it is definitely unusual to have 75 flights on time. Guys, if you have any questions about the binomial distribution, please let me know. Have a great afternoon.